Hello community, and welcome back to this channel and to this first installment in the Threejs Fundamentals series, which will be starting today with this video on BoxGeometry. Now, of course, the aim of this series is to illustrate certain fundamental building blocks in Threejs. We'll be going through several elements of the geometry for sure. We'll be talking about some of the core functionalities of Threejs, some of the most important functions, some of the most important objects and constructors that you can use for your programs. This will all be kept pretty standard and pretty simple so that everyone who is an aspiring Threejs developer and may or may not have prior coding knowledge can follow along. And we'll be diving right into this pretty much. I've already set up the basic file structure for a program. You're gonna need an HTML file, which is called index. You're gonna need a CSS file, which I've called styles, and a JavaScript file called script. These naming conventions are standard. Now, before we start coding anything, what we want to do is we want to have a package.json file, and the way that we declare a new package.json file is through the command npm init. This would suffice, but there's a boilerplate version thereof, which is npm init-y. This will automatically generate a package.json file with all the attributes that you need set to a default value, which is perfectly fine. And this will be where we can also view our dependencies when we add any, because we have to first and foremost install Threejs, and we do that through npm install free. If you want to save yourself some time typing, you can just say npm i3, press enter, and our free dependency is going to appear here in our package.json file. This will also generate a package lock.json file and a node modules folder, which we do not have to worry about now. The only thing we're going to do additionally here is we are going to declare the type of our program, and this is a module. So the reason that we do this will become apparent in a few minutes when we start programming our app, but suffice it to say that it's gonna cause some problems with the modern import syntax from ES6 if you don't specify this. Okay, so we're done here for now. We can start programming. So, or rather coding, because we're not actually going to be writing any logic into our index HTML file. So to speed up your HTML coding, you can start with an exclamation mark in your projects. This will generate this boilerplate, which is, absolutely fine. It has all the things that you need. And here in the title, we can just say BoxGeometry. Since we have an external CSS file, we're also going to specify that this is a link to a relationship, which is a style sheet, and this also has a type, which is text/CSS, and then we also need to specify the actual path that we're going to link to, so href styles.css, and this is how you close it. Now, the next thing you want to do is you want to embed the script reference into your body tag. This is traditionally done for loading reasons, so your script doesn't load ahead of time. So source script.js, and this is how you close this. Okay, and here we can very simply say h1, just so we have a heading, and it's going to be Threejs box geometry. Right, so if we click go live in VS Code, this will prompt a live server to be opened on port, in this case 5500. This will make it so that when you launch your code this particular way and you save any changes in your files, these will be automatically reflected in the live view of the site. There's two alternatives to this. One is the traditional one to use NodeMon, which is a dependency which made you launch your program and have this automatic refresh and automatic alignment function to your code. But a more modern version now is to use Node Watch, which is the Node environment's answer to NodeMon, pretty much. One is more modern than the other, but I find it just really handy to use the live server extension in VS Code. So if you're using VS Code, waste no time and just download it here in the extensions tab. Okay, so this is how our app is looking for the time being. Pretty lame, if you ask me, which is why we are going to add some styling right off the bat. So we have dot done for the rest of our project, and we hopefully don't have to waste too much time styling anything. So the first thing we want to do is we want to select everything in our project, as well as everything before and after. These, by the way, are called pseudo elements. And what we want to apply here is box sizing, border box. Now, this just makes working with the sizes, both relative and absolute, in our code a lot easier. Because when you start using a lot of different measurement units and a lot of values for different parts of your code, for different elements in your code, this can result in unwanted outcomes from a sheer layout perspective. So sometimes if you think you're applying, for example, 500 pixels to an element, but then you're also adding, padding or margin or whatever, at the end of the day it could be that your element is more like 505 pixels for whatever reason. And box sizing really keeps everything smooth and contained within boundaries. So the next thing we want to do is we want to select the HTML and body tags and apply a min height of 100 view height. The background color that I find most comfortable to work with in the 3D medium is black, because it makes me focus more on the geometry itself. If that is not the case for you, that's perfectly fine, of course. And I also like to have no overflow on the y-axis, so I like to not see a scroll bar to the right of my view. So this is going to be hidden. We're just going to be seeing the scene. Then we're going to be declaring that the body has a font size of 1.4 rem and that the text rendering is optimize legibility. So this is going to make a difference in the way that the text is rendered. Of course, we don't see this yet because it's black, just as the color of our H1. So let's just say that our H1 is going to have first and foremost a text align center property, so it's in the middle of the screen, and color. I personally like orange. It's a bit of a Halloweeny setup, basically. But you can see this is already optimized for legibility quite a bit. Better characters, better sizing of the characters themselves. The font is smoother and more legible. Okay, so this is our basic setup for styles and for our index. Let's move over to the script file, and what we're going to do here is import everything as free. This is the convention from free, from the dependency that we installed earlier. And the first thing that you want to do is you want to create a scene in Threejs, right? So before we dive into this, it is worth explaining a few basic things about Threejs. So Threejs is a library which is built on top of WebGL. Now, without going too much into the details and the historical details as well of how WebGL was used before Threejs and what Threejs adds specifically, just let it be said that Threejs is a library filled with many objects and helper functions which you can use right out of the box. Whereas WebGL is a very sort of primitive, low-level implementation of geometrical constructs. So with WebGL, you wouldn't be able to work right away with some of the more complex objects that you find in Threejs. You would have to write them yourself, which doesn't mean you couldn't, or that it wouldn't be powerful in doing so. It just means it's a lot more work, it's a lot more rudimentary in its approach, and it requires a deeper understanding of programming than Threejs does, because with Threejs you have to understand the library and how to work with it, but you don't have to necessarily understand, for example, how vectors or certain objects or certain helper functions are implemented. You just need to know how to work with them. So the basic elements in a Threejs scene are first and foremost, of course, a scene element. So this is how we declare it, const scene. And here we are going to be working a lot with constructors. So new free.scene. And as always, I suggest you to try and read as much of the documentation as possible. There's really no substitute for that, whatever you do. But we are going to walk through these building blocks and explain what we're doing. So this is a scene object. So as the description here that you should be able to see is telling you, scenes allow you to set up what and where is to be rendered. Right? This is where you place objects, lights, and cameras. So the scene is really the core element where you place everything that is going on inside your scene. It's intuitive, of course, because you're setting up a scene, there's a scene object, but I think it's still very useful to understand that you place everything inside of it. It's a bit like a stage in theater, yeah? Or if you so will, it's a canvas where you may project your ideas, your geometrical constructs. Okay, so the next thing that we need is a camera. Of course, if we're going to be looking into the scene, we need an object which allows us to do this. And the object that we are going to be using is called a perspective camera. Yeah, because the perspective camera has a perspective projection. So we are going to be working with some values here. We're going to be taking the values pretty much from the documentation. 75, which is the field of view. Okay, we can look at the properties again. Field of view, aspect, near plane, and far plane. Because what you have to understand about the camera in Threejs is that it works with a shape, with an object called a frustum. A frustum is like a pyramid where the top half is sawn off. Okay? This is what allows this perspective of the scene. And here we're setting the parameters. So the 75 is the field of view. Then next we're going to be setting the aspect ratio. And what could the aspect ratio be if not the inner width of the window object divided by the inner height of the window object. Next we have the near and the far plane. 01 and 1000 are the typical values that you would provide here. So we have a scene and we have a camera. Now the next thing is very important because this is what actually makes us render our objects and our scene. So we have a renderer, which unsurprisingly is again pretty intuitive WebGL renderer, because as I said before, the Threejs library is built on top of WebGL, and there's certain elements that are transposed into this library as well from WebGL itself, and the main element that you find expressly mentioned is its renderer. Until that we can define the renderer's behavior, or no parameters at all, which are then set to default, which is what we're going to be doing in our case. However, in the next step, we are going to be setting the size of our renderer. And here, again, we provide the inner width property of the window object and the inner height property. Only in this case, we're not actually dividing anything, as you can tell. finally, we have to append the renderer to the DOM. And this is how we do it. We use the document object, we select its body attribute, and we call the append child method, append child node, that being, as you can tell from here, node.appendChild of type node, and node is of the argument node is of type node and returns a node. And the argument we provide is renderer.DOM element, right? Because now we are actually specifying that this is a canvas where the renderer draws its output, right? So, and it's interesting to know that it is automatically created by the renderer in the constructor, but you just need to add it. You need to say, hey, I'm adding this canvas element to the page. Okay. So far, so good. So we've set up the basic elements in our scene, but now we need a geometry. As promised in the title of this video, we are going to be working with a BoxGeometry object. How do we do this? Also pretty simple, const geometry. And this again is going to be a constructor box geometry. Okay. So there's also an alternative to this, which is to use a buffer geometry, but we are not going to go into that yet. For now, we're just going to keep this very straightforward, just as the documentation would, and we're just going to walk through the code here. So what do we need to specify in here? Width, height, and depth. Pretty straightforward. Let's just say 1, 1, and 1. The next thing that we need for our geometry, or for our cube rather, that we're building, because this is what we're programming, essentially a cube, is to vest the geometry with a specified material. How we do this is so: const material new free.mesh basic material. We're also going to be talking about the different types of materials in a different video. This is the go-to option if you're just trying to write the most basic material possible, or if this is the only material that for whatever reason your object can work with. So here we can specify a color for our material, and what we're going to be specifying is, so this is our hex. This is something like green lime, which I'm showing you because it is typically the color that the Threejs tutorial works with, but I'm actually more of a fan of keeping this in style with the orange attribute that we've provided in the heading. So this is the hex, or it should be the hex for orange. And so far we have our geometry, we have a material, and we have declared the color for our basic material. Now, we have to combine these two things, because right now we just have a geometry, we just have a material, but as you can tell, none of these two constants are actually being used in our code. So what we can do is declare another constant, and it's called cube. And here we're going to be using the object that brings the previous two qualities of our object together. It's called a mesh, and it takes as an argument the geometry and the material. Right. So now we have a cube, but our cube is also unused so far. So we have to add it to our scene. This is the scene as we have declared it up here. Scene.add cube. Alright. And we are going to be declaring a z-axis position for our camera. And the standard value for this is 5. Right now, we still can't see anything. Now, why is that? Well, the reason is that we are not actually rendering anything onto the scene. Remember, at the beginning of the video, I told you that you have to work with the three objects: a scene, a camera, and a renderer. And I told you that the renderer is responsible for actually producing the computation onto our scene, if you so will. But is there any logic in here that does this? Well, obviously not. Which is why we are now going to write an animate function. Okay, this is called technically a render or animate loop. Function animate. And here we are going to use request animation frame and call the animate function you see the request animation frame takes a callback, which is the frame request callback type. Now, put simply, the request animation frame is responsible to draw the scene every time the scene, or the screen rather, is refreshed. So on a typical screen, this means 60 times per second, right? And request animation frame has a number of advantages instead of using, for example, set interval. I believe the documentation also references this point. And for example, it pauses, it stops the refreshing of the screen if the user changes tabs or navigates away from the view, and it's therefore optimized really for processing and for battery life more in general. It's very resources savvy of an animation compared to a set interval. Furthermore, we have to call the render method on our renderer object, and we have to pass the scene and camera. So as you can tell, there's always this recurring logic in different parts of the code with Threejs, where you're declaring new instances of an object, like for example here in mesh, and you have to provide previously declared objects in order to actually build the scene or the object as you envision it. And here we're doing the same thing. We are providing scene and camera objects to the render method so that they may actually enter the render loop and be projected onto the screen through the camera. We need to, of course, call the animate function, don't forget that. And now we can check the progress of our cube, which is not particularly working. I suspect this might have to do with the color being wrong. I have quickly checked the hex, but it seems to be okay, so let's look at the console. Okay, cannot use input statement outside of module. So the specification that we've added here doesn't seem to be working. So one thing we can do is to see if the specification in here helps, even though I suspect we will still have an error, and this time we will have this. So just let me very quickly change the input logic and I'll come back to you. Alright, so I fixed the issue. What you want to do is remove the module declaration from here, and you want to go into a CDN link that I will provide in the description, and just copy the script source manually into here. And this is perfectly equivalent to what we were doing before. It's really just a different way to set up the syntax, but you're going to find the updated and working version in the Git repository anyway. Okay, so the result of what we've done so far is this. Now, of course, this is a bit off to the side, and if we inspect the element specifically, we can tell it has to do with the canvas element in HTML. This is responsive, it's fine. We can actually just move it a bit to the center. So we could say canvas margin auto, and this is a syntax which will typically center your elements. It's a well-known trick, so to speak, to center a div. You're gonna find it if you Google how to center a div, and it's worked for our canvas component. There's many different ways that you can do it. You can experiment a bit. It's definitely worthwhile to tinker around with the stuff, because your go-to solution may not always work when you're trying to center something. Okay, so now we have this box, or this cube, which is fine, everything's working. However, it's not particularly 3D, is it? So let's see if we can add some logic to make this proper 3D. Otherwise we would not be using this library. So what we can do in our script file is we can work with the rotation properties of the cube itself. So inside the animate function, because we want this to be rendered and we want this to be refreshed every time the screen refreshes, cube.rotation.x. And here we're going to say plus equals 0.01, and here we're going to do the same thing for the y-axis. Okay, so this is really just our way to say you have to rotate by this measure on the x-axis and on the y-axis, and this is going to be incremental. So this is not going to start from the position of the cube plus 0.01, but it's going to start from that position, then each time it's going to be incremented by 0.01. So every time that the whole scene is rendered anew, every time the screen is refreshed, the cube rotates on the x and y axis a bit further, so to speak. It advances, and this is really just our way to declare a spinning cube. Okay, actually what we want to do here is probably move this logic in between here so there's no issues. Format so it's all nice and neat, and as you can tell, this is indeed a rotating, spinning, orange 3D cube on a black background.